Well, hello everyone, and welcome back to the first stream in a little while. Cacti Crown says first. Well, yes. Yes, you were. Good job, good job. See if I can sort out my cable mess here. So we seem to have some people in the stream. That's always nice to see. Do let me know if my audio levels are all right, as always. My Wi-Fi sucks. Well, yes, my internet connection overall sucks by today's standards. Unfortunately. I've been meaning to renew that, but who has the time? Anyway, let's get the show on the road, shall we? So I haven't been streaming in a while because I've been having a little bit of a cough going. And I still have a little bit of a cough going, so let's hope I can actually do this now without just coughing every other second. That remains to be seen. Anyway, today we are going to be working a little bit on this entrance here to the lift station. It might look a little different than you've previously seen. So I'd like to introduce you to the dingy, dirty, slightly scary looking gatehouse of lift station number 17, also known as the Minerva station. This is a house that I've been working on for the past couple of days. I'm also doing a little bit of painting and cleaning up of this actual wall here in preparation for the demo. My Wi-Fi crashed, I'm back. Oh. Yeah, it does seem to be a little flaky then. I'm glad you're back. Let's hope it pans out. Yeah, so I've been basically... actually, just my microphone here a little bit. I'm hearing a little bit of distortion here. Let me know if I'm too loud or too silent or anything. So anyway, I've been basically just banging out assets lately for this area, trying to get this level finally in a demo ready state. Getting kind of close. There's not like a whole lot of stuff here that's still in block out shape. This monorail station here, actually everything related to the monorail, you can see it going all the way over to the refinery, and everything here is basically still block out stuff. This is incidentally also the only thing here on the refinery side that's not done. Everything else here should be done. In the lift station we have some other things as well. We have this strange little house here which like is missing some parts. It's kind of like this ruin here, this ruined house, but just like a version that's not ruined. If that makes sense. So when I made this thing, I made like a house that wasn't ruined, and then I ruined it, and that is now this remains here of this warehouse. So basically I just have like this other version here, except it's sort of like lacking some detail here on the outside, and I'm just gonna throw it here and didn't really think about it. It needs some proper thinking. This whole area here with the entrance to the cave isn't really used for anything yet. So that's sort of like a missing piece. And then we have the monorail here being very block out-ish still. This warehouse here is now done, at least demo wise. Here you can see what happens if you have a light mapped area with some dynamic objects that don't have light probes yet. These things just look completely unlit. Everything that's like dynamic in here just looks absolutely unlit compared to the rest of the place. If you turn off the light map here, it becomes a little bit more balanced. Now you can sort of see that, oh, okay, everything is kind of like the same level, but of course now everything just sort of looks unlit. And so light probes, sorry, are still to be placed here, but I think this house otherwise is starting to be pretty good. And that goes for almost everything. I think this entrance here is mostly done except for the actual gates. The actual gates are still not textured. They're also going to be light probe lit because they actually move sort of in and out in this fashion when the thing opens and closes. So we won't actually light map them, and instead they will use light probes, but I don't have any light probes in this area of the map yet. So even if we like properly texture these guys, they will probably look like a little bit out of place still for a little while. That's just how it's going to be. But basically what I could start by doing is to model and texture these guys. We have a third one over here, which technically isn't even openable in the demo currently. This guy is just sort of sitting here. It's the exact same as this. I think it's a refinery sliding door. And we have these other ones here. These are actually scripted to open when certain things happen. And actually related to that, we have this display here, which is just empty currently. This guy, and indeed this whole building, was put here to solve a few issues. one of those issues is that we need like a way to signal to the player that, oh, actually, sort of like a power outage in the base. And so we could experiment a little bit with like how that would work and what that would look like. Cacti Crown asks, why did you decide to make your own engine and not just use an engine like Unity, Unreal, or Godot? That's an excellent question, and the answer is long and and actually there are many reasons, but I guess one of the most prominent ones is the fact that I've been working on this engine for a long time, for around 15 years or so. It hasn't always been this advanced, of course. But this editor that we're looking at now, this application here that we can drag around and dock, this thing turned 10 years this year, and before that, the engine was a thing like for several years without any editor. So I've been working on this thing for quite some time, and when you've done that, you've sort of grown used to actually working in a certain way, and you kind of don't want to throw that away. You kind of want to see where that takes you and what you can do with it. And this whole project, which is now called Traction Point, it's sort of like an attempt to see, okay, I have this thing, what can I actually make with it, right? There's nothing wrong in using Unity or Unreal or any other pre-made engine, but I just happened to have this thing, and I was like, I wanna see what I can build with this thing. 15 years, yeah. Actually, probably more than that. I've been saying 15 years now for like about a year, so it's probably close to 16 years soon. This engine's older than me, yeah. Yeah, in some ways it shows. There's some kind of archaic stuff in here. Of course, I've just like ripped out a lot of stuff from it over the years. But yeah, it's been going for a long time, and if you're not like a superhuman, then building an engine like this, especially if you're alone or in a very small team, it's gonna take a long time. It's not something you do in like a year, unless you've done it before and you know exactly what you want. But that does not concern. That's not my case. I'm not a superhuman, nor do I necessarily know exactly what I want. Anyway, but yeah, if you wanna build a game and just use a pre-existing engine, then do that. There's nothing wrong with that, not at all. So, which one should we do first? I don't know. I've been modeling like really a lot lately, so maybe it would be fun to just like do this text thing here, which is probably less modeling and more messing around with materials and shaders and things. Hey Tutu, welcome back. It's been a while. It's been a little while. I've tried to save my voice a little bit and not do a huge amount of talking, due to some sort of bug that my kids brought home the other day. Yeah, let's make a test with this display thing here, and let's see what we can actually make of this. I might even do the gates in the same stream. I don't know. I kind of want to just wrap this area, but I've been doing so much Blender and modeling lately that I kind of want to try doing something else for a little while at least. So the idea that I had, let's see if we can find like a suitable image here. Yeah, something like this. So if you have sort of like a display like this with some sort of LED matrix or something, where these letters are sort of made up of dots, right? It's like a dot matrix of LEDs. Well, I don't know why it doesn't want to show me a larger image now, but maybe it doesn't. Maybe it doesn't matter. You kind of know what I'm going for anyway. Building looks great. Oh, thank you. Yeah, I've been just sort of banging out models now for this area. We have a few new ones here. If you just joined the streams, we have a proper building now for the warehouse, where we have some painfully unlit dynamic objects in it currently, because we don't have any light probes yet. It looks kind of out of place. And the outer wall is properly textured now, and these ground supports are textured, and essentially everything except this monorail station and then this strange cave warehouse combination here. Yeah, and this building is put here basically like to serve a few purposes. First of all, I want this bridge here, which like blocks the access to this area for the mother vehicle. I guess you can technically still perhaps go there, at least if you're driving the mother vehicle yourself. You can go drive it like this upper way, and you can get into this place. Maybe I can block that somehow, but I might not actually even really need to or want to do that. This bridge is here sort of as a visual hint that, okay, this is not the right way to go if you're driving this. You want to go here instead. And the other way is to provide some sort of display thing here. If you remember previously, we had this sort of strange sort of arc above this gate here. I had an idea that it would have some sort of holographic display on top of it, which didn't really pan out. And that arc was also kind of annoying because it made it tricky to just like lift vehicles over this wall if that is how you actually want to get into the base. So I just sort of I made this sort of thing here where it will sort of show any users, any typical arrivals at this lift station, what they need to do. And of course in the game it will then show the player that, oh, okay, there's like a power outage going on. Because if you're playing the demo mission, you have the objective to actually come here and drive along this road. And when you drive up here, Rowan, one of the characters, she actually says like, the power is out, and so she would have needed to sort of read it from somewhere, and then I'm thinking we'll just put it on that display there to sort of give it a hint to the player that, oh, there's an issue with the power. So I found a font that I'm willing to try on this. So I bought like some years ago I bought like a font package of 10,000 fonts during some bundle. Most of them are actually kind of bad, but every now and then you find really exactly what you need. So this is sort of like a dot matrix like font. Let's actually go ahead and install that guy. And what would be kind of nice here is if we had a system that would just allow us to write text dynamically to a texture that we would apply here. We would have a quad mesh, probably with some alpha cutouts, and we would just display the text here with some nice bloom or something. Excuse me, but I don't think I'm gonna do that right now. I can obviously draw text to the screen, but it's kind of deeply hooked into the sort of main pass of the of the renderer. I mean, maybe I could. Maybe I could actually use like a. Yeah, I don't know actually. Maybe I could sort of hack into NanoVG, make like another NanoVG context, and I could render text to like an off-screen render pass, and then I can, you know, show that there. That's kind of not that necessary because we'll only have basically like 1 or 2 or maybe 3 things to write here on the screen. But it would of course be kind of cool to do that, and then we could also localize that text. But I think for now we're just gonna like basically create some textures for us, and then see if we can get them to show up nicely. Because regardless of how we do it, we're probably going to want to work with textures anyway, right? So whether we load those textures from disk or we actually render them on the fly, the rendering will be the same, right? We won't have any like mesh letters there. At least that's how I see it. So let's do that. Let's get something cooking. Excuse me. Yeah, I apologize for any coughing. Any coughing to be had in this stream. In advance. So first thing, of course, would be like to decide what we actually want to. That's fine. What we actually want to show there on the screen. So if we just start by filling this with black, basically black, and then we put a text there. Power. Text also black. Let's make the text green. Actually, let's make it yellow for this particular text. Power outage or something. And then we'll find our wonderful dots all for now. You know, if we kind of consider that to be sort of written there, might even fit everything on a single line, but it might be nicer if we just put it on 2 separate lines. Power outage. Yellow is the best. Orange is bester than the best. Yeah, so it's like, you know, if we take this and then we just move it, let's put a little bit of spacing in between these guys. Make it like red, whoop, and then green. I think they all kind of work. I think green is the one with the most power, right? The green channel is the one with the most sort of what's the word I'm looking for? Perceived brightness, right? In the human eye. I think we'll probably need a yellow one and then a green one. The green shouldn't say power outage, it should say something, you know, proceed through gate or something. But of course, the way these dot matrix displays work is that all letters are typically the same size. Typically. I don't know, maybe we should go for having 3 rows or something. I mean, it doesn't matter if it's the same size or not. We can come up with whatever fiction we want here. But still, in the mission currently, when you arrive here, it's gonna go like, there's a power outage, I can't do anything, right? And then the player puts some things together, and all of a sudden you have power, and the gates open, right? At that point, it should probably just switch to this. I don't think we need like a you know, bad things text. I don't think we need a bad things text, because there's not necessarily going to be a bad things state. But we'll see. If these displays become very sort of prominent throughout the game, then I'll probably make a system where you can just render a text to a texture, and then you can set the color on it separately. Yeah. Well, we'll see. I think we'll go with these 2 for now. Not sure about this actual text though. What should that say? Enter. Lift station. I don't know. It can say whatever we want it to say. I think you should probably just say something about the gate. Enter through gate. Something. Alright. But probably the color will come from the material somehow. Right? I'm thinking this will probably be some sort of black and white texture after all. The thing that we'll actually want to print these guys to. So let's just bring it up. Whoop. Take away that. So let's think about this a little bit. If I go later on for the dynamic texture, then something like this is probably kind of reasonable to expect out of the system. It will fill a texture to black or clear a texture to black and then print text in white. Yeah. So then we would have sort of like put a stroke here. Stroke. Some other color than white actually. No fill. It would have sort of like a section like this that we want to, a section of UV coordinates that we want to sort of map to the whole screen. Yeah, I haven't I haven't thought about this, as you can clearly see. So I'm just sort of thinking out loud here. Actually, it should probably be something like that, right? If we want to keep the text at the same size as the other one, it should be something like that. So now it's actually the same size. Yeah. I don't know, something like that. Well, yeah, let's save this. We have a beginning here, so let's go to Gatehouse work, and let's just do this like display texts or something. And if we want to actually export this as a texture, then we probably want to define for ourselves here a slice which is a square. So it doesn't need to be like a certain number of units here. We can then rescale. We can export it at some specific size. It's actually kind of tricky in Affinity Designer unless I'm missing something to actually get it to be. If I want this to be 2000 by 2000, I have to be kind of particular about it. Right, so if I want it to be 2000 by 2000, and now I can we can call that square, and we can just give it some sensible name here. What? Duplicated. Oh, that's okay. Something like that, and then we can actually give it like some dimensions here. We can't make that box larger. That's stupid. Well, let's just make that like 1024 height. And now we can export this guy. Yeah, we'll put it into the work for now. Actually, probably shouldn't go into the work if I want the engine to be able to read it, but we'll see. One thing at a time. We of course also don't want those rectangles to be there. So we can just make sure that they don't get exported in the... They're only sort of... Oh, that's not what I want. I want them to be visible here, but I don't want them to be visible in the export. And of course, if we go with this, then it would make sense to put this probably at so that we can start mapping this from 0, 0, which would be up here. And then if this is like a 1K texture, then 512, or rather 0, 512 would be here, and that is where we would be mapping the other text, right? So let's put in a square background here. Let's make that some other color, yellow, and make it a bit thicker. Right? That would be like the full square, and we also don't want that to be visible in the export. That means that if we... I think there's some sort of guide system that you can use for this. You don't necessarily need to, you know, to mess around with things like this if you don't want to. But one kind of easy way to get like half of that is if let's see. Yeah, like we start from there. Yeah, that's a square. So that would mean that the bottom half would be around here, right? That doesn't look correct. let's hide some of these other things here. Right, so the middle is there. Okay, there we go. So there's the middle. There we go. Put that nested underneath that guy. Yeah, that's what I thought. This thing wasn't sort of mapped in a sensible way. Okay, that's better. And now, of course, if we want to, we basically have a sort of like the mapped area. We can just make this larger or smaller. This is the larger one. So how big do we want the text to be? I also don't know the exact aspect ratio of that actual display here. It looks to be sort of, you know, roughly what we're playing with here, so we can just squeeze it the rest of the way, if that makes sense. Yeah, I don't know. Let's just make it large for now and see where that takes us. We can always pretend that the screen is actually just a standard LED screen that just has like a like a dot matrix on it, a dot matrix sort of visual on it. Or something. I think that looks reasonable. Let's do another test export here by actually enabling those two. So 2397, yeah, that's fine. It doesn't matter if it's you know, an even number or anything. We can try to just make it fill up the entire. Actually, no, we want to make it fill up like half of it here, right? Because that other part is sort of sitting on. Yeah, that's good. If we make another test export now, right there. We should sort of hopefully see those guides there, and we do. Okay, so that's good. Now we can disable them again. Does my engine have bloom? It does have bloom. It's not a very good bloom, but it does have bloom. Yes. Yes. You can see a little bit of bloom from the sky here. And we can indeed, and we should render this with bloom, so to make it sort of look like it is actually sort of a screen that emits light, but probably not like a whole lot, just a little bit. Yeah, it's kind of a crappy bloom implementation, just like everything else with the renderer is kind of crappy. I'm really not a rendering engineer. Okay, so let's export this now to outside the work folder. Save. And that means that if we go into the asset browser here, we should be able to find display texture PNG. We can give it a format. So this is now an actual texture that the engine can refer to. Which texture format should we use for this guy? Let's ask Nathan Reed. This is a tip for you guys, if you're wondering this yourself. Understanding BCN texture conversion formats. there's a very handy, this goes through all kinds of technical things, how gradients work and all of that. There's a very handy table here, which is tells you basically like, okay, how big is it gonna be? There's like half a byte per pixel for BC1, and you can see what kind of data we can have with it. RGB plus optional 1-bit alpha. I think grayscale here is you know, probably a reasonable texture for this. We don't have any alpha. Maybe we will at some point. Typically what I use is BC7 for just like color maps. But I'm thinking like BC1 might be kind of nice for this. So let's make it BC1. And we need to kind of figure out if we want it to be UNorm or sRGB. That doesn't really matter since we essentially only have black and white. So let's just make it BC1 UNorm, like so. And then we'll have to make some kind of shader material which reads that guy and outputs only the white pixels, and probably like discards the other. Of course. Now I'm doubting myself immediately. Should we actually use alpha here? Yeah, that's a really bad way to view images. Where's my GIMP? GIMP is also kind of crappy, but at least it shows me what I want to see. Because like it's not going to be just black and white, right? There's going to be sort of grayscale pixels in there, and that's not really a problem with things like this guy there. That's not really a problem with the texture compression. But what I'm thinking here is that, like, should we actually alpha blend this thing? Does that make sense? Should be able to do that if we go here and we quite simply, well, first of all, we just hide that background that we created for ourselves, and we can do transparent background. Yes. So now we can see it here as well. Yeah, I don't know actually. It might just be easiest to use alpha blending with this. We can do like an alpha cutout based on, you know, anything. So if we have it as black, we can just, you know, that wouldn't really be a cutout, but like a fragment or pixel, you know, cut off based on some value. But that often gives those edges kind of a gnarly look. So what I'm gonna do for shits and giggles is to make this a BC7, and we can just use an sRGB there. It doesn't probably look all that different. What is alpha blending? Alpha blending is the idea of transparent areas, transparent pixels. So if you have, can I actually find it here? Like if you have a box like this, let's make this some color. get rid of the stroke. If you consider this pixel here, right? Let's drag the pixel on top of everything. I know this is a rectangle, it's not even necessarily square, but let's consider this is a pixel. This is a green pixel, right? It has a color, which is defined by RGB, and then it has an alpha or an opacity value, right? So that would make it, if each channel, and it has then 4 channels, each channel basically is mapped to the range of a byte. That's why these go to 255, because that's the maximum value of an unsigned byte. Or an octet, but let's just call it a byte for now. Then you have 4 bytes, that would be a 32-bit color. So a greenish blue, green or bluish green, and then some opacity value here. If you use alpha blending in your material, then whatever you've rendered behind, let's say if we've already rendered this P made out of dots here, and then you render this pixel on top of it with alpha blending, then you will actually see through what is behind. And so this is something that you can find in every single game engine out there. But in my engine, and I think this is probably something that most engines support, you have either no blending, which is the default, you have alpha blending, and you have additive blending. And additive blending is basically just like take whatever was already there and add the values. Basically just like take this 102 for this channel, read what was already there in the red channel, and then just add 102 to that value. And then if you don't have any blending, then it doesn't care what's underneath it. It just draws it on top. So in this case, since we have this this screen here, if you use alpha blending, then we should at least in theory be able to get like nice and smooth edges around those letters there. That's what I'm hoping. Right, so how do we want to actually do this? Let's make a very simple mesh here that we map to like the top one, the top text. Alright, so let's see now. I've been doing nothing but Blender for the past few days, but I still don't know how to do this probably. So this is a square. Then half of it will be half of a square. So we just take these two guys and now we have half of the square. And which way is it actually facing? It's facing that way. Okay. Rotate around X90. I'm probably gonna get it wrong, but let's see. Let's see what we can do here. So let's call this something like, it's not gonna go into the elevator, it's gonna go into gatehouse work and like display. Oh, come on, display quad blend, and we can open that texture of ours. Let's actually export it to the work folder as well. So I have some sort of work version of it, which I refer to here in Blender, and then we have like the actual in-game version, which I export there out of the outside the work folder. Sometimes they're different, sometimes they're not. Let's take a UV editor and open the display texts. All right, that's going to be interesting. If I remember how to do probably many of these things. If we make a new material here, let me just take like the image texture, and we plonk this guy into it. We plonk it into it, just like that. All right, so it's okay. There we go. Yeah, it's just it is quite simply just incorrectly mapped. If we scale this by half, scale half up. Now we need to scale the whole thing by half. There we go. And then we drag it up. So we don't need this to be see-through here in Blender. We just need the UVs to be correct. Again, if you really want to, you can do some fancy alpha cutout things, but I'm not really concerned with that. The thing that's interesting now is that like we have this guy, and if we quite simply shift the V coordinate or the Y coordinate, you know, by half, then you know it switches the text like this. Actually, I I did it the wrong way. I sort of went upwards like this. It does the same if you have wrap addressing, but actually what we want to do is go down there. But the idea is the same. Doesn't matter. I'd love to unblock your links if someone can tell me how to do it. Let's see. Constant reactions. Yeah, if anyone has any idea of how to allow that sort of thing, then I'll be glad to allow it for you. Let's quickly Google this. YouTube links in chat. Or is it maybe like setting on the stream itself? Is that how it works? Yeah, I'm sorry. I don't mean to be overly restrictive about these things. It's just that I've never really paid any attention to these kinds of settings. Let's have a look here if I can find it here on the dashboard. The only thing I can find on the internet is that someone else seems to have the same issue. If you stream options and setting, choose whether links are flagged as spam. We've set it where we don't want it that way, then it shouldn't get deleted. Huh. I don't see such a setting. I can find the stream customization here where like I can enable the live chat and the replay and the live reactions and everything. It doesn't seem to say anything about links, unfortunately. Yeah, sorry. I can look into that for the next stream maybe if I have time. Yeah, it's annoying. Sorry. You might want to join the Discord and then continue the discussion there. Wink, wink, nudge, nudge. Anyway, okay, so we have this guy here, and it is now a quad. It doesn't really matter if that quad fits inside this thing necessarily, if we just sort of clip the pixels that you know aren't there. Or we'll see. It might be an issue. I don't know. It might be an issue. We'll see. But in the meantime, let's just export this guy to an FBX file. And I'm just gonna export it as display quad basis mesh export FBX. All right. Oh, it failed to convert. Contains no meshes. Really? What do you mean? Is this not like a mesh? I think it is a mesh. Pretty sure it's a mesh. That's weird. Okay, now it's a mesh. Okay, maybe I did something weird. I'm not sure. Anywho, let's see if we can come up with some sensible material for that guy. But first of all, I'm gonna actually create a blueprint for it so that I can just place it in the level, just like any other object. Projectile, no, refinery level specific, right here. So, actually we can call gatehouse display quad. And it wants a transform, doesn't need to have any collisions or anything. And then we'll have a mesh. And we should be able to find the mesh if we just do quad. Actually, we don't find it because I need to restart this thing to find it, but we can copy it from here. Plonk it in there, and we give it some material, right? So that we can see something, and indeed we can see it here. It's single-sided, which probably makes sense. There's no point in rendering it from behind. I kind of render it from the front now. That's the Z coordinate. Maybe that's fine. Hey Matt. Dotty sounds like train stations. Sort of, yeah. There's this new sign here, which is supposed to signal to the player, you know, the power state of the station here. And so, I'm trying to come up with some semi smart way to render it in a flexible and nice looking way. All right, let's just fire up the material editor here. I don't know if we did anything to that, but whatever. The vertex format is going to be this beast here. That's the standard vertex format for the engine. We'll just leave it at that for now. We can specify. Actually, maybe we'll do that. Let's just leave it at that for now. It's not a shadow caster. It doesn't have ambient occlusion. The main render pass is going to be probably transparent, right? If we use alpha blending for this. And let's go with that. Yeah, the vertex format is kind of a beast here, but we only have like 4 vertices, so it doesn't really matter. Only explicit export is if you only want it to, like if you do like a mass conversion of all material, convert all materials. If you want it to convert as part of that, some materials you don't want if you only use them as a base for other materials. But that's not this kind of thing. We'll save this immediately in the gatehouse. Display text or something like that. And then we'll need to make so we have one render pass, transparent. We have two stages. We have a vertex shader stage, vertex shader input, vertex shader output. We quite simply need to do a transform of the vertex. Very standard vertex shader in that sense. Position, we do need the UV, just plug that out. Normal, sure. Tangent, sure. Binormal, sure, why not? I mean, tangents and binormals are only really used if you do some more advanced things like normal mapping, but it doesn't hurt to just send it straight through. The pixel shading is the more interesting thing. Let's make sure we have alpha blending on now. Let's see some of these other properties. Primitive topology is fine. Depth test is fine. Depth right is probably also fine. Yeah, all of that's fine. So, pixel shader input. We get all of that stuff that we wrote in the previous stage, and then we have pixel shader output is here, and here we also have the bloom color, interestingly enough. Right, so the color here doesn't really tell us anything. That's the color that's part of the vertex format. So what we actually want to do is get a texture resource, and let's find our display texts, power outage, and enter through gate. So if we just use the normal UVs like we have, we should get the power outage text with this, if I haven't done anything stupid. Let's sample the texture. Texture is that, UV is that, and output is that. If we don't give it any bloom color, it's not gonna bloom. Simple as that. Aha. Input is subscript UV2. Oh, right, we don't actually write to UV2 there. Let's get it from the UV that we actually write to. So if I now go back to the here, and we just plonk that into the material slot instead, what will happen? Hey, look at that. Right, so it's not like super beautiful, but you can still see that there's this clearly sort of proper alpha blending going on here. You can see the the line here from the grid sort of gradually fading away behind that thing. So I think that's probably gonna work out kind of all right. So let's just shut that down and reload this thing. We can actually put it into the level here. Let's see what we get. All right. So gatehouse. Actually, it should probably be a child of that guy. Gatehouse display. Yeah, we can see that it's actually copy this transform and apply it to that guy, and then we can move it to the correct position. Get the rotation exactly like we want. It's probably facing the wrong way. There we go. Coding while watching someone else code. Yeah. I've never really been able to do that. I've actually never really been able to code while doing anything other than code. One might say that I've streamed while coding, and I guess that would be true. I'm not very good at it, as I'm sure anyone who's watched my streams will say. This actually gives it a kind of interesting futuristic 3D thing. Here you can see like this just becomes mush when you actually look at it from this side. If we switch this to an anisotropic sampler and we go back here, it should momentarily you can see there's the anisotropy making it nicer to read. We should probably use an anisotropic sampler for text like this, even though it's a little unreasonable to expect anyone to be able to read it at that kind of angle, but still. So now if we make it like put it right here where it's just in front of that face, you can see that immediately when we move away, there's going to be Z fighting. So that's not very good. And we can do a little bit of like depth bias things to help alleviate that. But in the meantime, I'm just going to basically move it a bit further and see. You can see that it doesn't actually help all that much. Okay, let's see what actually happens if we apply a little bit of depth bias to it. We can just like inverse C buffer wants to have a word. I think I might have inverse C buffering. I don't actually remember. I know I've had it in like one of my renderers. But maybe if this is the sign that I don't have it, then maybe I don't. Depth bias 10,000. I think it needed to be a kind of a high value, right? I need to remember how this actually works now. Depth. Clip. No. now it kind of disappears into that. Yeah, this is sort of a rendering hack that I haven't looked at for years, so I don't remember exactly how it works. I do remember that depth clip actually has to do with like it being behind us, right? Yeah, you can see like if we go through it, then I think it's like the near plane which isn't considered there. That's why we see it. So that's not what we actually want. Oh, it should be greater. Yeah, okay. So I evidently don't have it here then. Yeah, because it's set to less. You're quite right. You're quite right. Okay. What? Is it maybe negative? Is it negative what we want? Can you even have a negative bias? I think you can. I think that's actually what we want. Yeah, look at that. Yeah. I need to probably like I need to research this a little bit rather than just throwing random values into my graphics pipeline here. But yeah, I think this is reasonable. This is one of those things that like just start out like feeling like a good idea, and then at some point you're just like, oh my god, I've spent 2 weeks trying to debug this thing now. Like, why does my freaking display not work properly? then you do it in some other way. I think this is actually looking pretty good from like a first glance, but yeah, I need to like look at a documentation for those things. But that's boring, so I don't want to do it right now. Okay, so we have the text there. That's cool. Now if we take apply a little bit of math here. Little bit of math. Where's the little bit of math that I want? It's probably here. Math operation. Let's plug that into that. And we'll want the vector 2, and we will want to add this by 0.5. So now if we change this, it should change to the other text. Enter through gate. Hey. Okay. So now we have those two texts there. I'm not sure like the layout of that text is all that nice. How come the texture is not visible as a whole, since you have no math applied yet? It's through the power of UV mapping half of the texture, half of the quad. So when I do the math in the shader, I do this. Like I just move it down there, right? And if I don't have any math, then it's that. If that makes sense. So it's a little bit of a hacky poo right there. All right. I got a window opening. Let's go. All right. Glad to hear it. Cool. So what we can do now to maybe make this look at least a little bit like we actually want it to look. I don't need to close that. Let's just minimize it. If I take this color, let's add like a, let's add maybe a blah 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 blah. Let's add a color here. Call this text color, and then we'll add UV offset here. And then rather than just reading that, I'm going to take that away, and let's do color vector parameter and vector parameter. So vector parameter I'm going to plug into there, UV offset. Color vector parameter is that one. And we'll take another one of these vector operation nodes and just do a multiply by that value. So now if we set this to yellow, what? That's not yellow. There's probably an alpha channel here somewhere. There we go. That's yellow. And export that. We should have it in yellow. Hey. And if I plug that into the bloom as well, we should have like a hell of a bloom going on. Hey, that looks horrible. You can see that my bloom is not the nicest. In fact, it is the worstest. But let's see what we can actually do with it. To just give it like a little bit of a flare. Power outage. I probably need to redo my bloom at some point. But who has the time to do all of these things? It's a little flickerish. Which bloom kind of tends to be, but not this much. It's extra flickerish here because we have this text here, which just kind of happens to fall in between those texels of the larger bloom levels. Yeah, it kind of works. I'm thinking it kind of works. It is very, very saturated though, and as we've discussed previously, we live in the desaturated land here, and we're working on traction point. So probably something like that. I don't know. Let's play the game a little bit and see what we have. So what tech stack are you working with, Tacticrown? What are you building, and what language and framework and all of that? Always fun to know what people are up to. Right. Power outage. How unfortunate. We can't get in. Monogame C#. Excellent choice. We used Monogame once during a game jam sort of thing, and it was a real pleasure. Honestly, don't really know why I haven't used it after that. All of the rest of the level is light map now, by the way, which is kind of nice finally. And I've even done like a balancing pass on the grass here, so you can see darkness here under this ramp, which looks kind of like that's how it always looked, but no, this is how it always looked. just completely flat. Stuff like that. Can actually just bonk this out of the way. It sometimes can be done, not always. Bonk. You're not really supposed to be able to do it, so it's good that it can be done. And if we take the monorail into the lift station, that's also the question of like how does that, what does that look like, that sign thing from during this trip. I think it looks kind of all right. I wonder if we should actually sort of fade that thing away over distance, because I don't know. I'm gonna have to have a think about it. You know how those things are, like if you have like road signs that have this sort of LED setup going, their viewing angle is actually surprisingly narrow. So if you're not viewing the sign from like basically exactly the front, then you almost can't see those LEDs being on at all. We could maybe replicate something like that, but not exactly that very thing, because like that thing is kind of high up in the air, and and it's supposed to be kind of obvious to the player, but maybe something with distance. It doesn't need to be scientifically accurate. I love the fog so much. Do you mean this fog, the one that I have, or I found out earlier today that you can do this, which kind of breaks the camera a little bit because it's trying to fit in that alcove there. I can just see inside of the building. Yeah, if you mean my fog, then it's actually kind of simple. So there's nothing fancy about it. At all. But I'm glad it looks good. I think it's like an exponential fog with open main gate. Yeah, it's like an exponential fog, and it has like a height-based element to it, which you can really only see if you go far enough away from something tall. Well, here you can see it in the background, for example. Those mountains there in the background are sort of affected more towards the bottom. Same thing with these things here, but also here you can sort of, annoyingly actually, you can kind of see like the top of the fog here. It's a little too visible. Probably need to tweak the fall off a little bit. If we go here and we go to the ambience controller, here we can see it. Yeah, so it's an exponential squared fog, and I'm using just the standard fog formulas, which you can find all over the internet for that. Yeah, if it's not height based, then it just feels like the whole world like this, and that this doesn't look good, right? So you need like a top and a bottom, and then you lerp between those. And I think I have a smooth step there, rather than just being a straight lerp. But yeah, I'm glad it looks good. Okay, so what do we do about this now then? This is actually working kind of good, kind of well. We need some way to actually control this thing. And currently we have the text color and UV offset. These are material parameters, meaning that you can sort of tweak them regardless of the rest of this node graph. But they're not runtime tweakable. They're not like a constant buffer or anything like that. Instead, what you can do is you can create variants of this material that you would then use. You would sort of switch out the material for another material, and that is something that we could do. I do wonder if it can be done from Zig though currently. Let's have a look here. Headlight, isn't it, or is it? Vehicle light component. So this is for the previous game, Project Slide. Yeah, it gets the mesh instance and it sets the material. Ah. Okay. Well, we do have the material exposed to Zig, and we do have the mesh instance exposed to Zig. Ah, look at that. We can actually do it. We can actually do it. So, that's nice. I wouldn't want to necessarily write C++ to do this sort of thing. I want to write it in the gameplay code. So this guy quite simply gets a material yeah, it reads it from the blueprint properties. One for when the brake lights are off and one for when they are on. And we could do something similar with our little sign there, where we could have different states, and then we could have different materials to actually show in those states. Wouldn't that be cool? And then if we went one step further and we made it scriptable, so you could actually call that from the script, because then we could drive it from the mission. So it could even start like even start like off, so it's not showing anything. And then if the mission is on, then we set it to display various things. Yeah, I think that's a sensible way to do it, because it can be done without like just spending a whole ton of time on this thing right now, which is definitely what I want. And then only the really the annoying thing here is that we can't like localize these messages, but that's not really relevant for the demo anyway. So I kind of like it. Let's go with this. I am going to probably take like a 10-minute break. And then I'm going to come back, and then we're going to do just that. I'm going to make this sign work for the demo mission. So, if you need to run in the meantime, thanks for hanging out. Otherwise, I'll see you in a little bit. Alrighty then, hello everyone. People are wondering where I am. Oh hey, Wookie, welcome to the stream. Yeah, you caught me during my break here. We don't know where the toilet is. That's the problem. Yeah, I had to manage some family business there while I was away. And I went to make myself a cup of tea so that I can hopefully yap through this final part of the stream today. I'm not coughing my lungs out. Coffee would be nice, but I think I'd just vibrate out of my chair if I had any more coffee today. Okay, coolio. So, what was the plan now then? We want to make a component that we can put here in front of this display. We want to make it scriptable so that we can switch from one state to another, and we want to make it so that we can have essentially a bunch of slots. Each slot has its own material, which then shows a different text there. All of that, and all of that we should be able to do with just a single Zig component. I think. So let's go try to make that happen. What did we call this? This was Gatehouse display text. What was it? Gatehouse display quad. Right. Okay. I think we should probably make it something a little more generic, so that we can we can sort of display these things in other places that might require like a just a texture somewhere, because that is really what this is. This is a texture that's put on a quad. Doesn't necessarily need to be a display of any kind. It can just be sort of like a decal. Like in theory, there's a little bit of implementation details perhaps with that, but you can even sort of technically make like this text here change if you wanted to be spooky. Then that is what you could do with it. So let's call it something like It's like a quad that has texture slots or material slots. Multi-slot quad. Like naming things is difficult. What do we call it? Dynamic textured quad. Or scriptable textured quad. I have no idea. Well, basically, if we make it so that it has a mesh, and the mesh. One thing that we need to actually check here before I get too excited about this stuff is there's something called, is it mesh data? It's probably like game object. Mesh component data is the thing. Yeah, mesh instances, right. This is a little bit of a hack. If you have a Zig component, then that Zig component can get a pointer to one of its siblings, and it can, well, do whatever it wants with that other component. It's just a Zig pointer then. The mesh component, which is sort of like baked pretty deeply into the core game engine, is not actually a Zig component, it's a C++ component. And so a Zig component can't just get a pointer to it like it does here, for example, in the vehicle light component. If you're writing a game in C++, you can just go like, okay, give me the mesh component that's the sibling of this guy, like here, break mesh light component, like this, get game object, get component, mesh component. And then this guy will have a mesh instance, and then you can set the material of it like this. We can't do that from Zig, because again the mesh component is C++, but what we can do is we can get a mesh component data. And there's a comment here explaining exactly what I'm telling you now. The mesh component data contains sort of like the interesting members of the mesh component itself. So it has the scene node, it has the mesh, which is like the actual sort of GPU representation of the data, and then the mesh instance. And the mesh instance is what we want here in this case. The mesh instance is the one that is placed in the world that we can change the material on. Excuse me. Dynamic textured plane, a scriptable textured plane. Yeah, it's not a plane. That's the problem. It's not the problem, but it's a problem. It's not a plane in like a mathematical sense. It's more like a quad, or something that I would call a quad, right? A plane is essentially infinite. It has a position and it has a normal, right? Or perhaps it has a normal and a distance to the origin, which is kind of like the similar thing, represented differently. But I know what you mean. Yeah, that's really kind of semantics here. Anyway, we should be able to do what we want through this mesh component data, so that's fine. So let's call this a material set maybe this would be like a material set component, right? It doesn't even necessarily need to be a quad. The mesh is whatever you actually give it, right? The thing that this component provides is a way to reference a bunch of materials and then set a given material on the mesh instance. So a material set, which kind of confusingly is the same name of the method that we're going to use, which is called set material. But material set is like a set of materials, and that is, yeah, let's call it that. So scriptable material set component. That is what we want. Naming is the hardest task in programming. It is, yes, it is surprisingly tricky sometimes to do. Let's see if we can just very handily copy paste some other component that is sort of just a little bit scripted. This one is just a little bit scripted. What is that? Expose property test. That's a weird one. This one, scripted nav mesh obstacle component. This looks good. Yeah, we'll take this guy. I have a snippet to actually just create new components, but in this case, what we want is sort of specific to a scriptable component. So let's call this script or scripted. It's called scripted material set component. We can essentially throw this on anything. That we want to change materials on from script. Material set component, like so. We will have some exposed properties, but but not these exact ones, right? We don't want that stuff, and we don't want anything related to nav meshes. This is a nav mesh related component, so it's gonna have all manners of things here that we're not really interested in. I'm just commenting out these things that I kind of know that, okay, yeah, I will need that later. And we have a script API which looks something like that, and then we have a public API if we want to. Remove from nav mesh. Yeah, we don't need that either. Coolio. All right. Now then, let's go to components.zig, which is right here. And we just need to register it here with this guy. And actually, this is very useful in many different places in a game such as this, because quite often you have something that you want to change, some part of the material at runtime, and it's we have it running, so we can't build it. And it's just sure, we can say no, not a problem. Maybe I actually kind of don't want that saved. I want to take that guy away. We can disable that blueprint because that was sort of like a first test. I'm gonna make like an actual nice game object type for that. Which uses our new component. So let's get rid of that. Bye bye. And now we're gonna unload this guy, and then we'll go here and we will quite simply just disable that thing. We can set it to be disabled right there. Until we know that we don't want it anymore. In fact, we can just delete it. It has nothing of particular interest to us here, so that's fine. Okay, so this guy now then. I don't really support arrays of things as exposed properties. You can kind of hack it in the editor to allow you to do that. If you have known upper bound, let's say you have a maximum of 10 things, you can sort of set it, or you can hack it to the editor to only show like a certain amount of them. But that is a little bit of a hack. So let's not have that. Instead, let's have maybe 4 or 5 different possible materials in this material set of ours, and then we just have those slots visible there, so that you can set the material, and then we can have 5 different sort of texts to show in that display, which is like more than enough for now. And we can make this nicer later if we have a use for 20 different materials for something. Right, so how would this work now then? We have like material 0. This would be basis, probably renderer. Actually, is it resources? Material resource pointer. But actually what we want to store here is the path to that pointer, right? So we go here and we go basis, exposed properties, resource ref property. This is the thing that I actually want to use. Let's search for this and see. I think it's actually wrapping a string. Some resource ref. Yeah, okay. So it works like this. You have as members, as fields in your struct, you have a string. You wrap it here using a resource ref property, and you can tell it, okay, this is a reference to texture, for example. So we'll want to use material here. And then you give it the name of the field to use. And that will mean that we can store the paths to the materials to use as strings or string hashes, but we'll actually want to use strings here, so that if you then load up that level later on and you look, you actually get the string representation here. So let's have 5 of them like this. And like I said, we don't really support any arrays, so I need to have them as individual objects here. Material 0, that would be a material. Right, my OBS is letting me know that there was some hiccup in the stream there, so hopefully you're still with me. Alrighty then. So, right, that would be that. Those are basically just like, I think those are the only ones that we need as exposed properties. If you want to script something, you also need to have the actual script code container as an exposed property. That's just sort of an implementation detail of Basis. And then we will want to basically have a few methods here. So register component method. Let's have like maybe like a visible, set visible or set enabled true false thing here, so that if you know if the display in this case is like off, then it would hide it completely. So something like this, and then we can fill in here. It's gonna complain about that because it doesn't know what it is, but we'll fill it in just a sec. The other function that we will want to have is set material index, and this will be just int index. I'll do an underscore set material index for that as well. All right. Do we need something else? Like, this thing doesn't take into account at all you know, what kind of material it is that you're feeding it. It doesn't care what kind of mesh it is that you're applying it to. It kind of just figures, the user probably knows what they are doing. So that's kind of how it works. Oh, we need actually the address of those things. So then we can go here and actually like add them. So fn set visible self basis int pointer and visible bool like so. They're both voids. Void returning things. And maybe they should actually wrap just like a standard pub fun set visible bool. Actually, this needs the self pointer and then visible bool, and this would also return void. And this is then the thing that actually does the actual work. So this way you can call it from both the scripted side and just from Zig code in general. Set material index like that, and we'll fill in those things in just a little sec. Like so. Take that away and just do the same thing for this guy. Int 32 or I32 rather. Right, so we need to do we need to jump through some hoops here to basically get the pointer from the scripting environment so that we get an actual Zig pointer which we can then call these things on. Righty-o. I have to go bye. Well, thanks for hanging out. See you later. We don't need any of that. Take that away. On object created could be kind of interesting to have sort of like a initial index, right? That is something that we should then probably add as an exposed property. So if you have an initial index of like 0 or higher, it would just set that material when the thing has been created. If it's -1 or something negative, then it just would basically hide it. Maybe we'll do that. So let's put in here. Actually, I'll add it here before this. So initial index. Let's make that an assigned I32 so that it can be negative. And actually, we're in Zig now, so we need to initialize everything. In particular, we need to initialize and make that just -1. But these material ones, they need to be initialized with an allocator. And of course, we could have these, you know, as an actual. Oh, what do we have? 1, 0, 1, 2, 4, 5. What? Excuse me. Yeah, these could be in an array. Maybe that is what we should do. Should they be in an array? Maybe they should. So that would be material materials. How do I do arrays in Zig? It's like this, right? And then this would be materials is a whole array of things. Basically, they just need to be. Actually, I can probably use that strange double multiplication syntax to actually initialize those guys. Where is it actually? Don't I actually call any kind of method here? I don't know. Let's see if this works. Like that, maybe. Yeah, I haven't been writing a lot of Zig lately. Perhaps annoyingly so. Self-materials. And we need that to be a pointer, and then we can do m.d in it, right? Right. And we can get rid of that. And then we need to... Oh, this is actually interesting. Will this actually work? Let's hope it will work. So these are strings, but they are compile time evaluated strings. So I don't think I've used them like this, but I think that should work, shouldn't it? No field name material. Does that mean that we actually need to annoyingly have them there as individual strings and then... Yeah, I bet that does. Okay, well, this is something to keep in mind for later. I'm gonna want to actually make it possible to have arrays there. But for the time being, let's just make this actually work the way I had it. So 0, 1, 2, 3, 4. It's the same as there, and it's the same as there. We just need to call dinit on all of them. And I think when we actually refer to these guys by index, we'll want to create like a like an array, just like a temporary array that, you know, refers to those guys in a handy way, so that we can actually refer to them by index. Okay, that's cool. Now then, let's make sure this builds before we go further. Yep, it does build. Cool. So we will want to have a mesh component data object. This is the thing we looked at previously. So game object.zig. Mesh component data. Short name. Right, so you can tell it which the name of the component you actually want to control. Coolio. We can take that and we can shorten it a little bit. think I'm gonna shorten it to just mesh component data, and this guy will have one of those things. And we initialize it to default value. Now, the question is, do we want to actually expose that name, mesh component name? Maybe we'll do that. As yet another string, and I think that is luckily the last string we're gonna have to deal with here. Let's put it in the same order. Right. And this is actually not a resource ref, it's a string property. And this can probably be set to mesh, because that is typically what is used if you have just one. Good. And then we don't want to forget the initial index. So exposed properties, property, parent type is self, type is i32, field name is initial index, default value -1, 1, and empty string for the options. Okay. I realize there's a little bit of boilerplate and setup here, but we're almost done with this. So now in the onObject created, we'll want to get the mesh component data. Actually, the first thing we want to do is get the game object. So self.get self.context get game object, and then from the game object we can get the mesh component. Mesh comp data. go.get and assert mesh component data. Short name would be self.mesh component name, probably str. Right? Yes. So it will give us an error if we have that name incorrect. And if self.initialIndex is larger than or equal to 0, mesh comp data. Actually, the mesh instance is the only thing that we really want to control here. It's fine. Let's just use it through the mesh comp data. So that would be true, and mesh instance set material. Right, now within the material pointers, we actually want to probably get those during. Yeah, we want to just basically get. Let's see now, because this is actually kind of nice. Even though we need to have these as separate strings because of this stupid exposed property map thing, what we can have here is something like this. So here we have shapes, 4 of them, physics shape pointers. We initialize them to null, and we use this 2 multiplications times 4 to actually apply that over the whole array. So that's the fixed size array in Zig. And we can do the same thing here. We can do materials, and we have it set to 5. And this would be basis.renderer.material pointer. We can shorten that as well. have it like that. And we set it to null as well, and we apply it over the whole 5 materials. So here we have 5 material pointers initialized to material pointer null. This syntax is a little strange. I feel like that way at least. And then we want to actually populate those pointers with something, but let's do that in a second. I'm just gonna do basically this thing here where, you know, I set this to the self initial index, submesh index. I'm gonna leave that as 0 for now because I have very few meshes that have multiple submeshes, so it's probably fine. False. Actually, let's not create this visibility thing here. It can be set specifically and explicitly if we want to. Okay. Right. So here we want to go from 0 to 5, and we will want to actually do like a pub const max materials count is 5. Can use that everywhere. Right. So we want to initialize those materials based on the material paths. Let's actually have these be called material path. This or that. Material path and material path here as well. All right. Right. This is now the place where it's kind of annoying that we have to map those indices to that list of things. So how do we actually want to do that? PTRs is max material count of pointers to strings, and we'll want to basically do it like this. I hope I get the syntax correct here. Actually, that I probably don't even need to do that. I can probably just do. Yeah, it goes like 5 out of unknown type, but that's fine. We'll just use it and see if it can figure out what it wants with us. So let's do const mat is self. No, actually basis dot resources dot resource manager, acquire resource, and it gives us like an optional material if you give it a path here. So we want to give it a material pointer, mat pointers I str. All right. And we could we could use acquire resource or error here, which might be more helpful if we want to make sure that it actually gets the proper one. I'm not sure. I don't know. In fact, we don't want that because these are they're always going to be maximum 5, unless you're going to change that, of course. but the last ones might be empty, right? So if material pointers I is CLS doesn't want to show me the doesn't want to give me any help for this now. It's not annoying. Oh, that's because I renamed those. It's my fault, as always. There we go. That's why. Yeah. Alright, so if it's not empty, then we do this. And here we can now use acquire or error. And we can actually set that directly to materials, right? I. So they can be empty, and that's fine. That just means that the user doesn't need a material in that spot. But if it is given, then we want an error if it's like trying to access some material that doesn't exist. Right, let's make sure this builds. Unable to resolve comp time value. Right, we have the same thing here. Path. Tuple field access index must be comp time known. Oh. What? That's strange. I'm just doing this in the most sort of obvious way that I know how to do it right now. Let's see. Do this. 1, 2, 3, 4. 1, 2, 3, 4. Does that work? We'll do that one in 32. Aha. Yeah, that's a little strange that this doesn't work in my book. What if I make it like explicitly that? Does it still not work? Now it does work. Okay. That somehow makes it even weirder. Or maybe it's just something that there's like a subtle sort of difference if you let it infer the type where it becomes a tuple, or you tell it that no, this is a an array with the count of 5. Yeah, it's a little strange, but okay, let's go with it. Right. So I think this should be mostly it. We just have to actually do the thing, right? And that should be easy. We basically do exactly this. If we have the material index, just set it here, and index goes there. And visible, that is quite simply this part. Set visible. Visible. So after all that setup, the actual logic there is like super simple. The complex stuff is actually like holding these things in memory, and you know, the exposed property map system is a little clunky, can't be denied, but it handles all of the serialization, deserialization, and undo, redo, and all of that for you. So in that sense, it's kind of nice. All right. So now that we have this, now we can create that type that we figure we would have, and then we can add one of those guys to the level, and we should be able to basically immediately start playing with it, because we can create like a test script which allows us to change that index there. That should be great fun. Before we do that though, let's actually turn this material that we had, let's save this as gatehouse display base. And now we actually want to tick this box here that says only explicit exports. We don't want this particular material, like, well, we can export it like that, but we don't want it to happen during mass exports. It really doesn't make any sense. So we'll take those away. Bye-bye. And instead what we'll do is we'll create a variant out of this. And the first one would be the power outage, which actually happens to incidentally have the correct values here already. So we can just save this as gatehouse display power outage and export that. And then we want to have another one which is like basically gate open. Like so. And in that case we want to show this enter through gate text or whatever we end up calling it in the end. So 0.5, and then let's change the color to a greenish one. Like so. Save and export that. Right, so now we have two of these things here. We can hook into our new component. So that's nice. Alrighty then. Let's go here and let's add it to the graphical blueprints, I think. So graphical, and what did we call it? We call it scripted material set quad, right? I think that makes sense. And then we'll add a component to it. It will be the mesh component. And it's called mesh. And this will now have the quad, the display quad, but let's move that some... Actually, no. You know what? We don't necessarily want to make this a very, very generic thing. We want to make it a very specific thing that just happens to use a generic component. So actually what we want to do here is... let's copy the name again. I'm going to call this gatehouse display text. And this will use the quad that we used previously. So mesh component, okay. Quad, display quad. And as for the material, I don't exactly know what to use here. So let's just do like a fallback. No, it's not. There's not a fallback, but there's a blockout. Actually, isn't there like a? Is it a checkerboard? There's a checkerboard texture, but there's no material. Okay, that's. All right, let's use one of the blockout materials just to have something here. Maybe a brick. That way we know that if we see the blockout brick material there in the display, we know that okay, it just hasn't like it doesn't have a material set for it. But we will set the material by using a component type like this, and we'll call this scripted material set. And it complains that it doesn't know what it is. That's fine. That is absolutely fine. We want to set a few things here though. We don't want to render a thumbnail, and we don't want it to block the nav mesh. We don't want any global illumination for that guy. That's completely fine. It shouldn't affect the light map or the light probe, because it's basically like almost not there when it comes to like editors and things like that. Okay, and this guy, right, so I have to confess I kind of forgot a little bit about of the fact that the mission actually runs on the server, and we definitely want to trigger this on the client. So we're gonna have to wrap this in like a propagated value if you want to actually control it from the mission. But in the meantime, let's just run it only on the client, and we can run the script on the client as well. That's no problem. It's just that the mission can't control it, but we can control it through like a debug script for now. So that's completely fine. That's actually something that I kind of I do kind of often. I forget that. Oh right, the script runs on the server, and then you just have to create like a propagated value or two to ferry the data over to the client. Okay, let's see if this works now. Let's make sure we have this thing built. If we load back into the level, should be able to see the thing here. It doesn't have a thumbnail because we asked it not to render one, because it doesn't really make sense. But we can create the thing here, and it will look kind of like similar to what we had previously, except now it has this brick thingy here. And here we can see mesh component name, initial index, and all those material paths that we gave it. And if we click here now, it gives us like an actual sort of browsable list. So here we can do the power outage one, and we can do the what was the other name? Display gate open one. Right, so if we set initial index to 0, it should show the first one, and so on. Pretty cool. Again, let's actually copy the transform here and then bring it over. And that way we have the rotation exactly correct. Then I'm gonna scale it up again. And it should basically fill the screen here. Something like that. Yay! Isn't actually... It's a little offset from the screen, right? it might be completely fine. Have it offset from the screen. Yeah, there's a little bit of Z buffering issues there again, but that will be solved again with the depth bias if you want to have that. You can see that when we click it, we can actually script it here, so that's fun. So if we add like a function here called power, we can do self set material index to 0, and if we have another one which is like gate open, set material index 1. And maybe we'll want to actually have set visible true. Come on, set visible true. And turn off. And that would be set visible false. Alright, so now we have 3 functions. How do we call them? Well, if we add this dev attribute before them, then we can access them from the development menu. Okay, let's see if this works. I'm a little nervous, to be honest. Zig resource type mismatch. Oh, interesting. Let's export this thing, just that we can run it from Visual Studio Code, and we should be able to look into those debugging issues much more easily. What is the launch? Yeah, okay, that's fine. We want to load directly into the level. Right, so now we can break here, and what are we getting? Acquire resource, Zig resource type mismatch. Material pointer. I'm referencing something that I shouldn't be doing at that point. We want to go to resources and go material resource pointer. That is what we actually want to get out of that. So we want to get a material resource pointer, and we call that res ptr. We can't assign that directly to that one, but from the res ptr we can get the shared material, which is what we want to actually assign. I equals that, and then we can release the material reference or the resource reference. And actually, oh yeah, the editor is running. Unload that. That line is a little long, so let's break it into multiple lines. And there we go. Hey, power outage. And now if we run this gate open, hey, enter through gate. Turn off. Turns off. Power. So it does work. That's cool. I'm not sure about these texts yet. That might not be exactly what I wanted to say there, but it does work. Maybe it should actually blink. Should do something like this. But now we can drive this with a script that causes it to blink if we want to. that was a lot of work for relatively little gain. Okay, so how do we drive this now from the mission then? Oh. We are not releasing some references here. Ah, of course. Of course. We want to release those material pointers, righty? Oh, so we have this guy here. Basically this thing. Let's put it here after that. So we need to basically do if init null. Yeah, well, we can do this. If that is not 0, it's the same thing. Then we do materials I release. Right. So material resources are ref counted. And so once we are done with one of those resources, then we release it here, right after we've acquired it. But materials in the renderer are also ref counted, and we need to be able to release those as well. So yeah, that's what that was about. Now if we run this and we switch it a few times, we should be able to shut the game down without actually breaking it. Let's just make sure that happens. So power, gate open, turn off, and then shut down game, and it shuts down nicely. Cool. So, right, how do we drive this from the script from the mission now? Then these functions in the script API, these will be called from the mission script. And that runs on the server. This row here, as well as this row here, these need to be run on the client. And also, this needs to be run on the client. So, how do we do that? Well, first of all, we can toggle this to be running both on the client and the server. That's the first thing to do. Then we need to communicate to the client from the server one boolean and one I32. So let's see if I can remember how to do this. Let's do propagated value would be basis network propagated value, like so, and we probably want the handle as well. So we want the PV material index. That is a propagated value handle for an I32. Alright. Int index. Yeah. Absolutely. Good. Yeah, we don't need to initialize it here to anything. And then we need the PV visible, which is a propagated value handle to a boolean. And PV material index, we need to initialize this here in init, and that goes into here, probably the value, not handle. Init context is context. Name is PV material index. And here we can set some reliability things. So reliable propagation. Yeah, probably true. Immediate is false. Doesn't need to be immediate. Initial value can just be probably 0. So that's the material index, and then we need the visible. That's almost the same. Initial value is true. Right. And we also need to remember to deinitialize those guys. All right. And so now, here we need to check if self context on client. Then we run this thing here with hooking up the mesh component. Actually, we can probably just do all of this only on the client, because all of this has to do with like actual materials. Yeah, all of this is just stuff that we only want to do on the client. Good. This is client only data. Alrighty then, and right, so now rather than just calling set visible here, or actually here maybe, what we can actually do is call self PV visible set visible. And we can do this regardless of if we are on the client or the server. If it's on the client, then it just isn't propagated anywhere. It's just set. But importantly, what we want to do is we want to hook up some unchanged event handlers. So if self context client, here we want to do PV material index set value changed callback. I'm gonna have to see what the actual prototype here was. So it's that basically. Right, so here we want to do this actual thing, on visible changed. We want to make sure that we are on the client before we do that. So if self context on client, this should only happen on the client, but it doesn't hurt to be explicit about it. On visible changed, and let's actually just comment that out for now. Local chain value time, yeah, we're not going to use those. And then we have the index or material index, if we want to call it that. And that was index, and it was an I32. And this is where we want to set this other thing, like so. And I guess technically this could be something even smaller. This could be like an i8 maybe. Should make that an i8. And just less stuff to send over the network. I'm not gonna have more than 255 materials anyway. So let's make it an i8 there. Alright. I'm gonna have those auto fixes there. Good. Alright. Actually, maybe I don't want them. I'll take them away from here as well. And it doesn't hurt to have this client check here too. So now we have basically everything we want, except we still need to hook up these callbacks. So PV material index, propagated value callback, right? So this will be basically propagated value for an i8.callback.init, and we are initting it as a method. So the receiver is self. The receiver type is also self with a big S, and this is on material index changed. Like so. Right, we need one more bracket there. Like that. And then we have PV visible. And that's a boolean, not an i8. Right. Int cast once more. Alright, so to recap what is happening here, this gets called by the script. It can get called by the server or the client now, but the most likely thing is that it's going to be called on the server. And what happens is that we set this this visible propagated value to whatever it is. It will essentially not really do anything on the server other than setting it. But on the client, it will call on visible changed, which is where we check that we are indeed on the client. Maybe this should actually be an assert, because this should never happen on anything other than a client. So let's make it actually an assert here. Like that, and same thing here. And why does this only happen on the client? Well, because we only set these things on the client. We only hook up the value changed callbacks on the client. That's why. So now we run this, and we execute that script on the server. It should still change. So we can run script. We have a few of them that we can run on the client. We can, for example, change this still to gate open, and it changes. But now we can change it back to the power one on the server, and this is the important part that this works. I wonder if we can see it on the network stats. Probably not. There's so little data. Power. It changed very little, but that was probably something else. Well, yeah, this is now the idea, and the important part here is that we can do it on the server because we can hook it up to the script that runs on the server for the various things that happen. So that's kind of neat. Right, this actually now changed to power outage. It's no longer the red one because that code runs in the client in the editor as well. On object created runs in the editor. That's maybe not something that we really want to do. I actually kind of want it to be that red one there. Let's unload that and do like and self context in, not in editor. Right. So only run the logic if we are in the game. There we go. So this is red, just like we want it to, but if we run the game, it should go to the power out state. Yep, good. All right, I just need to figure out what exactly to write there, right? And we should be golden. I think even this bloom works sort of reasonably well here. I don't need to lose any sleep over this, I think. Works well enough. Coolio, guys. That was the stream, I think. One might wonder, okay, how do we actually now hook it into this script? And I guess technically we can find it. The script is not super clean here. Open main gate. I think that is probably what we actually want to do. So when we're opening the main gate, then it should change to the green one. I don't actually remember. Power station, blah blah blah. Power lines. Power cells. Power station. This looks good. Oh no, that's just some dynamic crates. Where's the receptacles? There's the receptacles. Power station object inserted. Okay. That's probably that's found here. Okay, add or remove power cell. I don't remember how this works anymore. Like, I'm kind of thinking that is probably what is actually like this is where we could send the message to turn that from the green to the yellow, or from the yellow to the green actually. But I'd like to actually verify that. And one annoying thing with this level editor is that you can't actually do like a global find in scripts. I should add that at some point when I have the time. In the meantime, we'll do it manually. Map refinery, because the level file is just text. Open main gate. Ah. Oh, you know what? It's actually probably sent from Nemo. Yeah. It's actually probably sent from Nemo. Yeah, send mission script message. Open main gate. So it's sent here. Exactly. Okay. So this is where we can send that message. Cool. Okay. What is this called? Gatehouse display text. Let's just call it text instead of text 1. Void. Oh. Void on. Come on. On message, like so. And if we call the message power on or something, then we set this to self set material index to 1. Right? Righty-o. We can maybe have a power off here, which is not currently used, but is sort of a good documentation for anyone reading this, that okay, that is how you could that is how you could turn it back off if you need to. And then the control script just goes and sends that message. So self. You know what? You know what we've done here? We've actually just forwarded the message. Maybe we'll do the same thing there then. Yeah, I think we'll actually do the same thing. So if the message is open main gate, we kind of forward it to the objects that are interested in it. Yeah, let's just do that. That's even better. Then we do the same thing here, but we need to send it to the correct correct object, right? So level objects. Oh, level object checked, and it's probably lift station, gatehouse display text, and it's the same message that we want to forward to there. There we go. That's it. Now we export the level. Now, unless I change change the actual level flow somehow, this should be really the only thing I need to do for the demo. This display, because in the beginning of the actually we don't want to load into the level this way. We want to run it normally. In the beginning of the mission, the power is off, and then at some point it is on, and then it stays on. Or now that I think about it, the player might be able to do some naughty things to actually get the power to be out again. so maybe it is actually not that simple, but still it's a matter of just switching that index back if that is the case. Let's see if we can we, like, I don't know if this is gonna work because I'm really stretching the script script flow here. If we just spawn like a power cell there. I'm not doing it in the correct place, I'm sure. I can't hit the receptacles if I do it there. Parcel. Yeah, I'm kind of breaking the flow of the script here. Can't quite do that. Let's try to just like only break it a little and see if we can actually make that reproducible. Now I'm gonna need to test this properly, but let's see if we can actually figure it out. So I think I can already open the main gate here. In the previous game, in Project Slide, I had a system that I called jump points. And jump points is something that I've used elsewhere in the industry as well, and that's essentially like scripted hacks to sort of oh, there's a visual glitch I can see. Those whatchamacallit, gates, they shouldn't be affecting the light map. Anyway, yeah, jump points are kind of handy ways to be able to jump forward in the script of a mission, so that you can, you know, test it and develop it properly without having to play the whole mission. It's not always super simple to do that because you need to move, you know, things around, and I have a lot of like dynamic things and stuff like that need to happen in order. But still, it's probably something that I need to think about a little bit, and it typically has to be sort of implemented separately for each and every mission that you want them in. There's rarely a system that just deals with all of those missions nicely. It's not impossible to do that, but it's kind of tricky. Quite often it ends up being just a feature of the script itself. Alright, so now if we close the main gate again, because we opened it through a development hack script, and I lift some of those, lift one of those power cells into one of these receptacles. Just spawn one here, power cell. Now the gate opens kind of properly, and lo and behold, the text has changed. So it does work. Very cool. Very cool. Okay then. Yeah, I think I'm pretty much done for today. Unless anyone have any questions about what we've done here. I know this is started pretty nicely, but ended up kind of a slow stream. Sometimes that's just how these things go, but I'm kind of happy with how this turned out. I didn't get to actually modeling those gates, but I think I'll do them still today or tonight offline. And then when that's done, now that we have the display working, this thing is this entrance here is pretty much demo ready. Pretty cool. Yeah, I have to come up with some nicer text for that display there. But that's something I can do. Anyway, folks, I think we've lost most of our viewers. Sometimes that happens. Not the end of the world. Still, I thank you for your time. Thank the people who are still around. If you are interested in this stuff and you would like to know more, then be sure to join the Discord, which is also where you'll be among the first to know when the demo is playable. And the only thing left to do now is to wish you a continued nice day and evening. And I'll see you in the next video. Have a good one. I'm gonna go drink some cough syrup now. See you later.